Hello everyone, I am Kristen Loven Armorillo. Furthermore, in this video, we will compare the Friedman test, a non-parametric test between our works and from the other site we search. Before we start, let's first have a short recap of the Friedman test. The Friedman test is a version of the repeated measures ANOVA performed by ordinal that is ranked data. Repeated measures ANOVA is similar to a simple multivariate design. In both tests, the same participants are measured over and over. However, with repeated measures, the same characteristic is measured with a different condition. For example, blood pressure is measured over the condition, which is time. In our works, solving Friedman test has 7 steps. First, defining the null and alternative hypothesis. Second, stating alpha. Third, calculating degrees of freedom. Fourth, stating decision rule. Fifth, calculating test statistics. Sixth, stating the results. And the last step is to state the conclusion. This video tutorial explains how to perform the Friedman test by applying the steps we got from the internet using Excel and a shortcut, which is using a Friedman test calculator. Let us do it first using Excel. From this website, it has 4 steps in solving the problem. I will use this process to come up with the same answer simply and easily. Moreover, the same way with the Friedman calculator I will be using. From our ordinal data search in the internet, 12 subjects are measured in different treatments in the table. Treatment 1, 2, and 3. Step 1. Enter the following data, which shows the 12 patients on 3 different treatments. Since each patient is measured on each of the 3 treatments, we will use the Friedman test to determine how the effects of the patients differ between the 3 treatments. Step 2. Rank the data values in each row in ascending order using the Excel formula or function. For the function or the formula, click the cell where you want to put your answer. In this worksheet, we will use the rank.avg function. Its purpose is to rank a number against a range of numbers. Click the cell G2, then type equals rank.avg open parenthesis number is the number to rank. Click the B2 cell. For the ref is an array that contains the numbers to rank against. Then click and hold B2, then drag to D2 cell. After dragging, then in this part, put the cursor to B2 and D2. Then press A4K until the $sign placed before the cell value. And for the last one is the order. Order is an optional rank, ascending or descending. Default is 0. Since it is optional, it's up to us, but for this time, type 1 for order so that the smallest value receives rank number 1. And do the same to the other cell, or you can just drag it sideward and downward. Now, you can get the rank of each treatment. Then, calculate the sum of the ranks for each column along with the squared sum of ranks. In calculating, click the G14 cell and type equals sum, S-U-M, then highlight the cell you want to add. In this problem, highlight G2 to G13 cell and press enter. Then, drag it sideward to get the sum of rank of other treatment. For the step 3, calculate the test statistic and the corresponding p-value. The test statistic is defined as k squared is equal to 12 over n times k times the sum of k plus 1 multiplied by the summation of r squared minus 3 times n times the sum of k plus 1, where n is equal to the number of patients, k is the number of treatments group, r squared is equal to the sum of ranks for the rth group. Next is to substitute it on its corresponding value, which will be 12 over, open parentheses, 12 times 3 times the sum of 3 plus 1, then close parentheses, multiply by the summation of r squared. Squared of 32 is 1024. Squared of 27 is 729. Squared of 13 is 169. Minus 3 times 12 times the sum of 3 plus 1. Then click enter. Equals 16.1666667 or 16.167. Under the null hypothesis, Q follows a chi-square distribution with k minus 1 degrees of freedom. We will now find the p-value. A k-square test will give you a p-value. The p-value will tell you if your test results are significant or not. In order to perform a chi-square test and get the p-value, you need two pieces of information: degrees of freedom and the chi-squared value. To know the p-value, we will use the Excel function, which is choosesc.dist.rt function. Just type on the cell equals CHISQ.dist.rt. For the x, substitute it by the value of k squared, which is 16.1666667, and the degrees of freedom is 2 since the formula is k minus 1. We have 3 groups, minus 1 equal to 2. The result is 0.000308641. Note, a p-value less than 0.05, typically less than or equal to 0.05, is statistically significant. It indicates strong evidence against the null hypothesis. Otherwise, a p-value higher than 0.05 or greater than 0.05 is not statistically significant and indicates strong evidence for the null hypothesis. This means we retain the null hypothesis and reject the alternative hypothesis. The test statistic is 16.1666667 and the corresponding p-value is 0.000308641. Since this value is less than 0.05, we can reject the null hypothesis that all of the treatments have identical effects. We have sufficient evidence to conclude that the type of treatment used leads to statistically significant differences in effectiveness. And for the last step, the step 4, report the results. Lastly, we want to report the results of the test. Here is an example of how to do so. A Friedman test was conducted on 12 patients to examine the effect of 3 different treatments. Results showed that the type of treatment used led to statistically significant differences in its effectiveness to the patient. That is, the chi-squared value is 16.1666667 and the p-value is 0.000308641. And that would be all for the Excel process. And another way, using the Friedman calculator, fill out all the data to the calculator accordingly. So here I have prepared already. So I just copy paste it to the other website or to the other empty calculator. After filling out, click the calculate button, then we will get the result, and all of them are the same as we have computed in Excel. And same also to the other website that I have searched, and which is all about the Friedman Test calculator. However, as we can observe, chi-squared from our works calculation was different from the Excel and Friedman test calculations because of rounding off numbers. On our works, 0.083 is rounded off to the nearest thousandths. That is why they come out with different answers. Well, mathematically, they are still the same. And that would be all for our report about the Friedman test. Thank you.